So, here's the deal. Because of absences today and whatever else, I was gonna collect the rest of your Chapter 3 homework today, but I am not going to require that be turned in. So tomorrow, you guys will continue working on your test. Mrs. Likens will be here, so she's been in a few times. She's been in with me before, and so you guys should recognize her, remember her, and she knows some of you. So you'll finish your masteries tomorrow, so please bring something else to work on, independent reading book or work for another class. That may not work very well. I got handheld sharpeners up here if you need, Nathan. Sometimes it works for people, sometimes it doesn't. Maybe you have the superpower. Shoot, I had another announcement. Oh, so if you want to turn in the rest of your Chapter 3 homeworks tomorrow, you can, or today, if they're done. I don't really care, but you can just stick them on a bin and they'll sit there and just hang out. That would be 333 through 3-3 closure. It's only a couple assignments. I forget how many exactly. I could tell you really easy. It's just 2 assignments. So it would be, yeah, just the last 2 in the chapter. If you don't, though, we'll just collect them Monday because, things should be a little bit more back to normal on Monday. So we'll collect those on Monday if you don't turn them in today or tomorrow, which is no big deal. I'm not going to require that you turn them in until Monday. What up?
So I'm probably going to go home. Instead of reaching out to my grandparents and also for letting me eat some of your bark, I bought you these.
Dude, this is not an even trade. This is way more.
I don't like Buckeyes.
Really? Oh, thank you, bud. What are you trying to sweeten me up for? Did you not do your homework?
No, I'm fine.
I'm just joking. You're trying to bribe me for something. Okay, truffles. I'm already mad at you about the truffles.
Okay, I only had 3 left. They were really good.
I said what I said. All right, so today we are picking up from what we were working on what was that? Tuesday. What's going on back there? Are we comparing biceps or something?
No,
I'm measuring tape.
No. Isaac just whipped me with his pencil and it hurt.
Isaac, apologize. Isaac, if you can't control your pencil, we can give you an independent desk if you need. So, who can remind us from Tuesday what we talked about was scale factor or dilation or this whole changing size of things? Aiden?
Scale factor is multiplying when we talked about basically just shapes and I remember we doing shapes and we talked about scale factor being multiplying.
Yeah. Your scale factor is your multiplier, right? So when we apply a scale factor, it is just multiplying, as Aiden said, but another name for scale factor is the multiplier, right? So scale drawings, if you look at the definition, is just changing size of something, either getting bigger or smaller. We also call that dilation, but because of that, this makes these shapes called similar. And as we talked about on Tuesday, you're similar than you used to be. Right? You're a different size, but Casey is still Casey. He's bigger Casey now, but same Casey as smaller Casey was. So that is similar. Now, when you travel, and if you ever want to look at Ohio maps, I have a bunch of Ohio maps, and there's one on the other side of that wall right out there. And I used to have one in this classroom, but I think I marked Otterbein and different stuff on that map over there. When you look at a map, is the map the actual size? No, of course not. That wouldn't make any sense. You unfold the map and it ends up covering all of Ohio, and people are like, no. But imagine if a map was the real size. It would be pointless because you could just look at the real thing. Right? So we use what's called a scale factor, and that scale factor is kind of dramatic here, where 1 inch measured on the map actually equals 5 miles. Or, on a map of Pennsylvania, 250 miles long, 450 miles wide. I don't know if you've ever driven through Pennsylvania, but it's big and it's annoying. 450 miles wide, guys. We can't, that's hard to fathom how big that is. If you look at Pennsylvania, it's pretty much like a rectangle. Not as tall as it is wide, right?
I had to go to a summer camp in Pennsylvania. The camp was nice, but it was just, It was a super long drive from where we were in Hilliard all the way to the place. It
Yeah.
was like 5 or 6 hours long.
Was that for your scout troop or what?
Yeah.
All right, so let's help Ulila, or you I don't know how to pronounce her name. Ulia.
Let's just call her E.
So E measures or determines that the distance between downtown Philly and Valley Forge is 14 miles. So this is like one of those questions where, as a 7th grader, you're probably like, duh. But like, did she actually measure 14 miles? No. She measured some relative distance on the map and then had to apply a scale factor. Right, so we're going to practice that today. So if your group doesn't have a book yet, one of you needs to grab a book because we're going to be measuring things in the book. If you don't have a ruler, grab a ruler also. So most of us probably need rulers. My rulers keep kind of disappearing, and you're supposed to have one, I think. I think it's on your supply list. So, yeah. So if you don't have one, I might have a couple here. I got a metal one that people need. Hey, do not smack the rulers. Do not try to bend the ruler. Like, those plastic rulers just love to break. Okay. Oh, no, take this. Don't go to your locker. It's such a waste of time. Anyone still need one?
I'm done.
I have 2 different broken ones that can together be a working one. Alright, so now I don't think we need those for one more question, but I wanted you guys to go ahead and grab those. So check out this scale drawing. Guillermo needs a scale drawing of his house placed on a suburban lot. The lot is 56 feet wide, 100 feet deep, and the garage is 20 feet back. So he has a sketch of his house not drawn to scale. Don't trust what this looks like. Trust the numbers, right? So like this 15 feet wide is not necessarily half of the 30. It might be, but yeah, it might be the same size as 7. Like, so it's not to scale. It's not perfect, right? We're going to use graph paper and at least a straight edge, but I don't know if you need a ruler quite yet, to determine or make a scale drawing. Now, here's the cool thing about your graph paper. It has a determined size. If your graph paper has bigger squares, it is probably 4 squares equals 1 inch. If your graph has smaller squares, it's probably 5 squares equals 1 inch. So you can check that right now with a ruler if you want.
Oh my
But
gosh.
I want you guys to determine a scale that you want to use, and we can just make our scale boxes so you don't have to have a ruler. Determine a scale you want to use, and then let's draw this. So I'm going to slide this up onto the TV and get my graph paper. Is it 4 to an inch?
Yeah.
We got to start somewhere, and we should start at the front right corner. So on your paper, leave some space up, but we're going to have to start at like that bottom right. So go ahead and put a point there. Now the first thing we know is the house is 8 feet over, right? And we actually know how far back it is too, based off the problem telling us. So first thing you want to choose is a scale for feet, right? How many boxes equals how many feet? We have 56 feet, 20 feet, 100 feet, 38 feet, 17 feet, 8 feet, 15 feet. We got a lot of different numbers here. So it's not like we can pick a perfect one that works for everything. We got to decide how much space I have. Right now, based off yesterday, know that I only have about 12 boxes to work with here, just on my screen, because it's only so big. I have more wide, but what number is a little bit nicer than 12? 10, right? So if I decide I'm not going to use my whole sheet, but I'm going to use 10, if I make my drawing 10 boxes tall, and I need to recenter this, what should my scale be then? If I'm going to make it 10 boxes tall, so actually, let's just all do the same scale for this one. Go ahead and draw this 10 boxes up, and then chat with your team about what that means the scale is, and you might have to read the problem again. I got to recenter my board. you might need to read the problem again to figure out what that scale is going to be. Think about how deep is the entire house, or how long is it? Let's use some random cards will be tough today. Do I have a volunteer to tell me how long the entire lot is? How deep that whole rectangle that we're looking at? Sky? It's 100 feet, right? So if I label this 100 feet, what does that mean my scale is? Eva? Yeah, that was a great start to the sentence.
Like you're taking it down by 10%.
Yeah. Like my drawing is 10% of the real thing. Well, so if I have 10 boxes equals 100 feet, every one box has to equal 10 feet, right? So I can write down my scale. One box is 10 feet, or this comes down to your paper. It's either going to be 1 inch is 40 feet if I have 4 boxes per inch. Or if you have 5 boxes per inch, 1 inch might equal 50 feet. Sorry, I'm drawing that wrong. This should only have 1 tick because it's feet. So depending on your graph paper, but we can actually just leave the scale in boxes right now if we want. Makes our life easier on our paper. So you can say 1 box is 10 feet. So if every box is 10 feet, how many boxes wide should I draw my drawing? Somebody new. A new hand we haven't had. How wide is the whole lot? That's what I'm going towards. Isaac, how wide is the whole lot?
100.
That's how deep it is. So we already got the 100. What other dimension? The lot is
30.
that's the house. The house is 30 feet wide.
15.
Now you're just guessing. Nor? 56. Look in the problem, Isaac. So in the problem, not in the image, but in the problem, it says the lot is 56 feet wide and 100 feet deep. See that in the text? Yeah? Joey, point it out in the book. How many boxes, Nora, I'll come back to you. How many boxes then should that be?
5.
Nora. If every box is 10 feet, how many boxes do I need for 50 feet? 5, and then like a half, right? Like another. So 1, 2, 3, 4, 5, and a little bit more. Really, this should be 6/10 of the box, right? But it's okay if you're pretty much at half. And then finish your rectangle, right? So this is the lot. Notice how much different ours is already looking than the picture from the book, because theirs wasn't to scale. And go ahead and label that it's 56 feet wide. So then to go 8 feet in and 20 feet back, right? The problem tells us the house is 8 feet in, 20 feet back. So to go 20 feet back, how many boxes would that be? 2. All right, so I'm going to start drawing the house in red. But then to go 8 feet in, Casey, how far will 8 feet in take me? Not an 8. Be careful how we say that. 8/10 of the box, so almost the whole box. So 2 boxes back, almost a box over. Anyone confused on why I put that point there? This is 20 feet back, 8 feet in. What do you mean, what part?
Never mind.
We're going to finish drawing the house.
Yeah, like, never mind.
After this step, let me know if you still have a question, okay? So the house is 15 feet wide. In that front section, how many boxes would that be? 15 feet. Kevin, what do you think? How many boxes would 15 feet be?
1.5.
1.5, right? So one box takes me to there, not like to the intersection, but then half of another box takes me here. So go ahead and draw that, the front section of your house. Then how far back from here do we need to go based off the drawing in the book? How far back do I have to go from this point? I head this way. From the drawing in the book. 17 feet, right? So how many boxes will 17 feet be? You know? Eva? Yeah, 1 and 7/10, right? So I go an entire box, and then almost one more. I stop right there. That might have been a tiny bit too far, but that's okay. How wide should this section of the house be? It doesn't tell us directly, but we can figure it out. Casey? 15 also. How'd you figure that out?
Because on the top of it's 30 and 50.
Yeah, the back section of the house is 30 feet wide. So we go another 15 feet over, so another entire box. And a half. So we're almost to that edge, I think. Yeah, because this didn't quite start at the intersection. This doesn't quite make it to the intersection. Try to finish drawing the house on your own. I'm going to give you a minute or two to try this. Remember, every box is 10 feet. So now we're going to go back. I'm going to zoom in a bit more on this up on the TV.
How is it going up 30 feet?
38? What do you mean how? Like that's the big section of the house.
Yeah, going up is like.
Yeah, so like from here, we got to go 38. So you got to figure out how many boxes that is. Then from wherever you land up here, the house's width is 30 feet. Right, we know that. And then this should just be connect whatever, like wherever you land, you should just be able to connect. No, sorry, Bob.
No.
What's 38 feet really close to? 40 feet, right? So how many boxes is it going to be really close to? 4. So it's going to be almost 4 boxes. So 1, 2, 3, 4. I don't quite make it up to that line.
You don't?
Not quite, because see how this one isn't quite at the line? So if we go 1 box, 2 box, 3 box, 4 box, I don't quite make the line. Then I can kind of see this in my head. If I think about my line coming up here, I'm going to have a point like right here at the back corner, right? Because my house is rectangular in that back section. I know that it's going to come straight up and straight over. And then we just connect it. And there's our house. So this is probably like a 3-season room, like a front porch. And then this is just the main section of the house. Like, I mean, most houses are just built like on a rectangle.
It's like a
A
hut.
hut? I mean, it's like 40 feet by 30 feet. That drawing was totally wrong, though. Yeah, Mr. Smith?
Just, sometimes I remember hearing middle schoolers ask, when am I ever going to need this? Just so you guys are aware, I have been doing this, and my garage is almost done building, and this is the kind of stuff I did first. And I literally got on the Franklin County Auditor site, and it told me how big my lot was, how many feet wide, how many feet deep. out graph paper, and I literally drew. I had a scale of 1 box equals 5 feet because I had enough space, and then I scaled it to 1 box equals 2 feet to make a more accurate drawing when I got into my lot. So I've done all of this as an adult in real life to actually, and I can see the project happening.
He also got to dig a giant trench in his yard with a big old backhoe thing.
Well, that too. Yeah. We have to use power tools and giant diggers. So.
Can we maybe show that stuff on Monday? When we have
I'll see that. Yeah, see what kind of photos and videos I have.
Like even just your graph paper sketches.
Oh yes, I should still have those too. Yeah.
Scott?
My stepdad does something kind of with this stuff because he's building a house for some strange reason.
Okay.
So then there's like he can't pass a certain limit.
Like a boundary line, yeah.
Yeah. So then he has to know like how big things have to be and stuff.
Same stuff Mr. Smith had to do, yeah. Could you push it like as close as you could to like the neighbor boundary line?
Well, the neighbor who was on the boundary line is actually the one who's helped me build it. So I made sure that I was a little bit even further to get a little extra space because he was going to help me out. Which some of the Wilson Hill kids know because I live in the Wilson Hill area, but it's a 7th grader's father.
Oh, nice.
He's at Kilburn Middle.
Very cool. So you guys, like, I love that Mr. Smith just shared. This is the real stuff, and this is what I tell my friends too. Like, I'm certified to teach high school, but I honestly believe this math is more important to you. High school math is fun and it's deeper and it's like tough and like, you get into calculus and really cool stuff, and then you could like build bridges and but most of you aren't going to do that. Might you be adding on to your house or building a garage or like yeah, you really might do that someday. But like that really high level math, that's narrower of an audience that cares about that. So now, because Guillermo's interested in a project just like this, he's speculating, what if I want to put a pool in my backyard?
No.
So you guys need to figure out, in this space back here, how big of a pool could he install? Let's say he wants to walk out his back door and immediately be in the water. What is literally the biggest pool he could fit into his yard? Figure that out with you and your group. What is the biggest pool he could build?
Providing building code.
Yeah, forget about building code. The wall of water will be right against the foundation of the house. We'll just use the foundation wall of it. Not with my foundation wall right now.
Okay, children,
That would be great to jump out your back door into the water.
Dude, I haven't wanted to take a picture of it, but I need to bring you a picture before we start doing the work.
So even with now that you got the stumps out and grinded,
I think it got worse. Like, it's not even worse. Well, actually, I now have like a fake box spring. So it's like really thin. Like there's no springs or anything, but it's like a foundation board for a bed that we don't use anymore. I put that out there with a tarp wrapped around it to like divert water away from that part of the house and just like try to keep that area drier. I think we're gonna need to excavate on the outside, rip out whatever needs to be there, and like push the wall back from the inside. So we'll see what happens. Ooh, okay, different question then. If Guillermo decides to put his pool in the front yard, how big of a pool can he fit here? No! Do it! No! Do it! Alright, now while Brendan calculates his front yard pool, who can tell me, Brendan, I'm coming to you next, figure out how big of a pool we can put in the front yard. Okay, I'll make it easier. How big, hold on, how big of a square pool could you put in the front yard? I'll let you do that.
Where is the front yard?
This is because it tells us street. Street is right here. Street is normally the front yard. So this is his back. Can anyone tell me how to figure out the maximum size of the pool there? Not optimal, but maximum. Joey?
You gotta do the edges and then the bottom part.
Okay. How do I figure out this right here? How did you figure out that distance?
The last 2 boxes, which makes it 20 feet.
It's it's a tiny bit more.
It's a little bit more than 20. 56.
Ooh, Sky?
Okay, so like on the thingamajigger, it says 38
So we knew that this was 20, right? Like 20 back. Then how long was the whole house? Brody?
The house was.
So this here's 38, right? What is this? 17. What is that together? What's 38 and 17? Do the 30 and the 10. That's 40, right? Then 8 and 7. Yeah, 55. This is 55. So how far back the lot have we gone? Plus 20 is 70. My drawing is slightly off. I goofed. My drawing is slightly off. If that's 55 feet, this is, then I should have only gone to the half box here. This should technically be 25 feet, I think. Because this was 20 in here. This total is 55.
Yeah, that left side, you were ballparking at 40.
Yeah.
And then forgot to.
There's my mistake, guys. We said what's close to 38. And this is real. Like, I'm not acting right now. Like, I said, okay, 4 boxes, right? But I forgot it's not 4 boxes. Yeah, Mr. Smith gets a piece of candy. So that should have only gone to halfway up the box. Notice how easy it is to make a tiny little mistake. But guys, that's like 3 feet extra on my pool, right? That's a big difference on my pool. Brody, what? Did you have anything else?
I just wanted to say, he could have saved a whole bunch of money just buying one of those, like, half jacuzzi, half pool things.
Those things are expensive.
Yeah, but he could have saved a ton more with time. Because his basement would have been flooded, and we did all this while we were moving here.
Yeah.
Our basement flooded, there was problems with, it was bad.
Yeah.
So,
Yeah, I'm having basement issues myself. That's why I'm out again, guys, tomorrow. Well, and I have doctor's appointments, but the guy is coming first thing in the morning to try to tell me what to do. Or, like, what they need to do. So, Brendan, what about our front yard pool?
40 by 20 something.
Ooh, what about square? I thought we said square. Eva, did you look at the front yard pool?
No, I just said 40 by
40
40.
by, why 40 by 40?
Because it has to be square. Like, okay. So, like, let's say, like, okay. Because with all these funky numbers around there,
Mm-hmm.
it's gotta just be hard.
We got funky numbers, she says. What? No, I agree with you.
So I said it'd just be easier to do it like that.
Is that 40 by 40?
No. Oh.
Ah, 20 by 20. Be careful with that. Now, your area would be 400.
That's what I did, but I made it
Now, here's another way that we can make our life easy.
bigger.
And this is slightly harder for you, but I like this. We seriously do this sometimes. What if and now the first thing you're going to tell me is, but I can't do that. I'm going to tell you how you could do this, like, on your own. What if I say, I seriously want the biggest pool possible? And I draw that on here.
What does this guy want?
Now his front door is here, so it's okay. This could be a sweet pool. But now, you know how you said I got funky numbers and like weird lines? What if same graph paper? How wide is my pool? 30.
30 by 40.
How deep is it? 37, 38, right? If I can move it and line it up with an intersection, makes my life a whole lot easier. So you could physically do that, like with graph paper, and like shift things over and cut or whatever you want. Yeah,
I know exactly why it's 38. Because if you look at the little dots right there, there's only 2.
you're really, really close though. How far was this?
20.
It's 37 because this is 20 and that's 17. So be real careful. It looks like it might be 38, but if I go check the math, it's only 37. So we got to be real careful with that. All right, we got to move on. We spent too long on that, but it's worth talking about because that's the real world stuff. because I had you get rulers, let's look at 14, like 414.
And also that would crush your house.
So check this out. You, in your book, want to measure the distance between a few different things. Sentinel Falls and Sentinel Dome. And you want to convert it to both miles and kilometers. Let's say we don't know what kind of car we're going to be driving. We don't know if it's going to be miles or kilometers. So first thing you want to do, and the problem walks you through this, is just physically measure. Right? If we just could drive in a straight line, physically measure that distance with your ruler in your book. Then use that and the scale in your book to convert it. So you are going to have to use your ruler and compare it to here, like lay it on top and figure out what is your scale actually. How far is 1 inch? What does 1 inch actually equal according to our book? Now, or you can measure in centimeters. If you want to measure in centimeters, you could do that.
Yes, the metric system is great.
Yes. Yes, sign out my black binder here. By the way, I'm gonna have my own sign-out sheet from now on because of the stuff going on, and I have some people like that chronically leave math class. I don't think much during this one because it's the first class of the day, but I'm trying to keep track of like how often the same people leave the same class, like my class specifically, and how much time you're giving up from being, in the bathroom or wherever else. So I've just got my own sign-out sheet now, as opposed to the one out in the out in the hall. What page are we on?
193.
Yeah, 192.
If I go and I try to compare inches, does it line up nicely? Does it? What does inches line up nicely with? 1 and 1. What do you mean? So I'm trying to say 1 inch equals. How much does 1 inch equal? Not a half. How far is this? Would you make a mark there with some kind of marker? Actually, you can just use your fingernail if you want.
At this 1 inch mark?
Yeah. Right there, guys. How much of a mile is that? It's not a whole mile. This out here is only a half mile.
It's 0.
Ah, I should not have moved that. 0 point how much?
0.5.
Now my book bends. My book's lifting a tiny bit from the bend. You guys, look at the first mark they give us, and it's not as bright up here as I wish it was, but that's a tenth, right? So if I count by tenths, 1 tenth, 2 tenths, 3 tenths, 4 tenths, so we could say 1 inch, and please write this for this problem, equals 0.4 miles. Now, it doesn't look like inches lines up great with kilometers, so maybe since that's metric, I'm supposed to use metric. So let's try that. If I try to line up the metric side of my ruler, ooh, how far is half a kilometer? 2 centimeters. So what can we say about like 1 centimeter? If 2 centimeters is, yeah, it's half of the half, right? So it's 1 centimeter would be 0.25 kilometers. Please make sure you have both of those written in your notes. 1 inch is 4 miles, or 1 centimeter is a fourth. Or sorry, not 4 miles, but 0.4 miles. And then a fourth, or 0.25.
I got 2.25 kilometers.
What? Don't. Oh, why are you doing a new file? All right, so then, how far did you measure here? Give me the inches and the centimeters if we have both. How many inches was it between Brendan?
About 1.5
1.5 inches.
inches. And was 4.5 centimeters.
Anyone verify those for me, just so we have to double check?
Yes, sir.
1.5 inches, 4.5 centimeters. Is that about right for us? You have what? How many centimeters? Are you saying inches or centimeters even? Inches. What'd you get? 1 and.
I got like 1.
So if we measure that distance, I can do it up here. Sorry, my computer's lagging out now. Straight line distance. So I think it's slightly over what we got.
Told you you were wrong. I know you didn't. I don't like being in a house by myself.
Sorry guys. Now my smartboard's opening I don't know what's going on. Weird. Check it, guys. If I line this up, I'm struggling with all the ink. My smart software has kind of glitched out, guys. Oh, this is failing. Best laid plans. Oh my gosh. Alright, well apparently my dot camera is not going to work very well right now. I don't either. Just give me a minute. Alright. We should have just gone with 1.5. That would have made our life easier. If we line this up, guys, it's a little over 1.5. Right? Now my camera's gonna fall if I let it go, but like, so 1.5 and another, what is 2 tick marks on my ruler? What's that worth? It's a 16th, right? So let's just do 1.5 and then we'll deal with the 16th. Oh my gosh, I don't know what is going on with my computer right now.
Maybe it's just having a bad
Everything's opening new.
I think everybody's having a bad day today.
So what would 1.5 be? What's our 1 inch? Our 1 inch is 0.4, right? What's another half of that? 0.2. And then a 16th of an inch. This is where fractions are a lot better. So, hey, I'm not asking you to do it. Think about your 4/10 that we had right here. Right? If we say 4/10 instead of 0.4, and then we say a 16th of that, check out how easy your life can actually be. So, we're not talking 1 inch anymore, we're talking 1/16. What can I do to make life way easier? We could just straight multiply, but there's something we could do first. Joe? Cross reduce.
Oh no, don't bring that back to the dead.
Hey, dude, I'm making your life easier. I'm making the math easier. So 4 and 16 can both divide by 4. This can become 1 and that can become 4. So really, I get 1 over 40 with it. And there's nothing left to do. So plus another 40th. And that's a little over 0.2. 40th is just over, or 0.02 actually, sorry, because this would be 2/80ths. Be 2.5 over 100. So 0.025, we shift some decimals. because it'd be 25 thousandths. And I know I'm doing like the quick math that when Mr. McCully used to do this, I was like, how does he do that? McCully, my old math teacher that kind of gave me the inspiration to become a math teacher. So really, what I would say here, kilometers would be a whole lot easier. Because kilometers measure out to that half-kilometer mark. Probably be a whole lot easier. We are likely going to need to pick this up on Monday. So tomorrow you're finishing Chapter 3 test. Please come prepared for that study tonight if you need to. Other than that, have a great day, guys. Yeah?